Hi, today I'm going to show you how to make a quick foldable in your notebook on scientific notation. So what I'm going to do is I'm going to kind of just visualize about half of my paper, and I'm not going to go halfway, I'm going to go about 3/4 of the page. So I'm going to fold up like that, and what we're going to do then is we are going to just divide this flap that we have folded in half and then in half again. So I'm just going to eyeball that. It's a little bit hard to do a half with the lines on this side, but that's okay. And we're going to do it in half again. So we have 4 sections, and we're going to use these 4 sections to take some notes on scientific notation. And then what you can do real quick is fold your paper down, and we're just going to cut to that crease that we made so that we have 4 separate flaps here. And if it's not perfect, it's not the end of the world. This is a study tool, and as we know in school, we are not perfect. We are always just working to be better. So we're going to take a couple notes on scientific notation. So on the top, I'm going to write what the topic is. So this is scientific notation. And we're just going to remember a few things about scientific notation. So what is scientific notation? We know that scientific notation is used to represent very large and very small numbers. Okay, so we're going to add that to the top here so we have the definition. Now, there's a couple things we know about scientific notation. There is always a power of 10. So there's always a power of 10 involved. And we also know that the coefficient in scientific notation must be between 1 and 10. Okay, so what does that mean? That means that when we are writing these, the coefficients, the numbers that we see before the base 10 can be like 1 and 2/10, 7 and 65/100. What they can't be though is like 12 and a half or 4 thousandths. Okay, that's not going to work. And if you're wondering what I'm talking about with coefficient and base 10, there's an example here. If we have 4 and 6/10 times 10 to the 4th power, this is an example of something in the proper form of scientific notation. You have your exponent, which is going to either be a positive number or it will be a negative number, which tells us a lot of information. You have your base 10, which is your power to the 10. That whole thing is your power. And you have your coefficient, okay? And we know that a coefficient is a number in front of a variable being multiplied by a variable. In this case with scientific notation, the coefficient is the number that we're going to be expanding to make very large or very small. Okay, and so this number must be between 1 and 10. It can't be greater than 10 and it can't be less than 1. So let's start by reviewing what is scientific notation and how do we change it. So what about for numbers larger than 1? So we're going to start with numbers larger than 1. Okay, so numbers larger than 1. Let's talk about that. All right, there's 2 forms in scientific notation. We have standard form, which is how we are standardly looking at numbers, and then we have scientific notation. Okay? So, standard form would be this very large number, 247,302,000. It's a very, very big number. What would this number be in scientific notation? Well, to follow our rules, the coefficient must be between 1 and 0, or 1 and 10. So what we want is we want to rewrite this number so that it's a number that's between 1 and 10. So what that means is that we would see our decimal is actually all the way in the back of this number, okay? So our decimal's right here, and we're going to move it up here behind the 2 so that this number is 2 And what would it be? 4 tens, hundreds, thousands, 10,000s, 100,000s, 2 and 4, 47, 302, 100,000s. Okay, so we're going to move this 1, 2, 3, 4, 5, 6, 7, 8 times. So we're going to move the decimal 8 times forward. So we have this large decimal, which is hard to read out. And I know we like to say 2.47302, but this really is 2 and 47,302 100,000s, okay? And I just give this a little bit of information. And then we moved our decimal 8 times, so it's to the 8th power. So what we notice here is that the exponent is positive. Our exponent is positive. So if it's a large number, it's going to have a positive exponent. And if we see a number in scientific notation with a positive exponent, what that means is we need to move the decimal backwards to see what this number is in standard form. And it's going to be a number greater than 1. Okay, so what about numbers that are smaller than 1? Okay, so numbers that are smaller than 1 in standard form, we know these numbers as decimals, okay? And in science, you're going to start seeing some really small decimals because real life situations are not perfect, pretty little numbers. So in this problem, I have, that's the tenths place, the hundredths place, the thousandths, the 10,000ths, the 100,000ths. So 1,300 thousandths, okay? So what would this be in scientific notation? What would it be in scientific notation? So, what this would mean is we want this number between 1 and 10. So, we're going to take our decimal place and we're going to move it 1, 2, 3, 4 times. So, this becomes 1 and 3 tenths. So, 1 and 3 tenths times 10, and we moved it backwards 4, so to the negative 4th power. So what you need to see here is that these have the exponent is negative. The exponent is negative. All right. And so if you see a negative exponent with a scientific notation, you know this is a very, very small decimal, and you're going to actually be moving, if you see it like this, you're going to be moving the decimal to the left to make it a teeny tiny decimal. Okay? So that's the basics for numbers that are larger and smaller than 1. Okay, so now that we've looked at how to write a number in scientific notation, we're very quickly going to review multiplication and division with scientific notation. Now, with multiplication and division with scientific notation, yes, I am aware you can put these in a calculator. If you put these in a calculator, and I'll make a little side note down here, you don't have to write this down, but when we're looking at things in a calculator, you're going to see them as E instead of 10. So for example, and I will do this on a separate page very quickly. For example, if you put a very large multiplication problem into your calculator. All right, so let's say I'm going to say 8 and 2 tenths times 10 to the 8th, and 7 and 1 tenth times 10 to the 9th. So these both have positive exponents, so they're going to be very, very large numbers. So if you put them in the calculator, how do you read your answer the correct way? Well, I'm going to show you really quickly. So if you put this in your calculator, what you're going to see is the calculator is going to give you 5 and 822 thousandths E18. So what you have to know is when you read that E18, what this essentially means is times 10 to the 18th power. So if you're going to put them in your calculator, just know when you see your answer, that is how we'd have to write your answer. Now, if you use Desmos is pretty great about giving it to you in scientific notation, but most other scientific calculators are not going to do that. So what if we're going to do it by hand though? Let's come back and let's talk multiplication by hand. So there's 4 steps for multiplication by hand. The first step I always use is to rearrange my terms. My second step is to multiply the coefficients. My third step is to add my exponents. So our exponent laws come into play here. And my fourth step is to make sure the answer is in scientific notation. Okay? And I'm just going to abbreviate scientific notation with SN. So let's do an example together. So we're going to do 8 and 1800ths times 10 to the negative 6 times 5 and 1500ths times 10 to the negative 5th. And I'm running out of room here, but that's okay. All right, so notice these are both negative exponents, so we know their number's smaller than 1. These are teeny tiny decimals. We don't want to have to write these out in standard form just to multiply them. So what we're going to do is we're going to rearrange. When I say rearrange, we're going to take our coefficients. So we're going to write 8 and 18/10 times 5 and 1800ths times 5 and 1500ths. And then we're going to do times 10 to the negative 6 times 10 to the negative 5th. Okay, so this I am totally fine. You can put it in your calculator. You can work it out by hand. It is totally up to you. For time, I'm going to put this in my calculator. 8 and 1800ths times 5 and 1500ths is going to give me 42 and 127 thousandths. Times, now we deal with our bases of 10. So we keep the base of 10, and what we're going to do is we're going to add these exponents. We're going to add negative 6 plus negative 5. And again, if you're not the best with positives and negatives, put it in your calculator. Negative 6 plus negative 5 is negative 11. So what this means is there's 11 decimal places all the way out here. So this is a teeny tiny number. Now, step 4, we need to make sure our answer is in scientific notation. This is not in scientific notation because 42 is not between 1 and 10. So what we are going to do is we are going to move our decimal place forward 1. So we have 4 and 2,127 10,000ths. This is now a number where my coefficient is between 1 and 10. And then, because I added a decimal place, I'm going to add 1 to the exponent. However many decimal places you move is how many you will add to the exponent. And this is true for multiplication or division. If you are adding decimal places, you add an exponent. If you are taking decimal places away, you subtract an exponent. So we add these together, negative 11 and 1 is 10 to the negative 10th power. And that is our solution in scientific notation. Okay, that is how we do multiplication. Division is very, very similar. Same 4 rules except for 2 things are going to change. Step 1, we're going to rearrange our terms. Step 2, instead of multiplying the coefficients, we will divide coefficients. Step 3, we are going to subtract our exponents. So we know from our exponent laws, or we should know from exponent laws, if you don't know, it's time to learn. Whenever you are dividing with the same base, you subtract exponents. Just like when we were multiplying with the same base, we added our exponents. And at the end, we're always going to make sure the answer is in scientific notation. Okay, so we're going to do one more example. We're going to do 2 and 400ths times 10 to the 5th divided by 2 times 10 to the 2nd. Now notice these are both whole positive numbers, and so that means these are both numbers greater than 1 when I write them out in standard form, so they're going to be larger numbers. So we're going to do step 1, we're going to rearrange our coefficients. So I'm going to do 2 and 400ths divided by 2 times 10 to the 5th divided by 10 to the 2nd. 2 and 400ths, we can just put it in our calculator, or you can do it by hand, either way. And when we do this, I get 1 and 2/10 times 10, and this is where we subtract our exponents. We're dividing with the same base, so we're going to do 5 minus 2 is 3. So I get 1 and 200ths times 10 to the 3rd power. Luckily, my answer is in scientific notation. I don't have to move any decimals, and I'm good to go. So this is a great review on multiplying and dividing in scientific notation, as well as writing numbers in scientific notation. It is ready to go. It's in your notebook, and it's a great tool to help you study if you have something that you are studying for. So I hope this helps you, and if you need anything else, check back and watch some of my other videos to review. Have a good day.